All right, ladies and gentlemen, welcome to another exciting AP Stats problem. So here we are. We've got our chapter 1, our first special problem. And again, this is practice FRQ for the AP exam, but we're using material only from our chapter 1 in our book. So go ahead and read this. They gave a survey. They gave a survey to some incoming freshmen at a selective private college. Doesn't say the name. And here are the scores they got. Okay. First thing I'd recommend doing, I know question 1 says make a stem plot. First thing I'd recommend doing is, let's put this data in our calculators. Okay. So to do that, if you have the 83 or 84, you go ahead and press the stat button because that's what we're doing, statistics. And the very first choice is edit. So I'm going to edit a list. So choose edit. And you can see list 1, I've entered the scores from the special problem. Okay, so list 1, there's all my incoming freshman women's scores on this survey of study habits and attitudes. Okay, so number 1, it says make a stem plot. Well, it'd be nice if these values were in numerical order. And I'm going to show you something you can do with your calculator. You can ask your calculator to sort a list in either ascending or descending order. Okay, so here's how we do it. Right above stat, you see the list feature. So I'm going to go there. To access those keys, we press second and then the stat key. So I just chose the list menu. Okay, here's a place I can find all the list names. If I go to the right, here's a bunch of operations, and you can see the first 2 choices are to sort. I can sort ascending or I can sort descending. I'm going to go ahead and sort ascending. Okay, now I need to sort list 1 in a ascending manner. So I could go back to the list feature, and you saw the list names were available, but the fast shortcut way to do it is you'll notice right above the number 1 is list 1. Right above number 2 is list 2, so on and so forth. So if I hit second and the number 1, I will get list 1. Now nothing's happened yet. I need to press enter to have the calculator execute that command. So as soon as I hit enter, it'll tell me, done. They've completed my command. So now when I go back and I hit stat and edit, okay, there's the data set, but it has now been sorted in an ascending manner. So that's pretty nice. That's going to make my job of making my stem plot that much quicker. Okay, so I'm going to jump over here. I kind of already got started. Here I have the stems 7 through 20. You'll see why I went 7 through 20 in a minute. Okay, so my first entry is 101. Put a 1 there. Then I have 103. And then 109. Okay, and then I jump to 115. Then it's 126. And another 126. And a 129. Okay, 137. 137. 140, 148, 152, 54, another 154, 165, another one, 78, and a 200. Okay, remember we talked about this in class. I cannot leave off the stems 18 and 19 just because there was no data that landed there, right? Your stems have to go in order. You're not allowed to skip anything. If I skipped something and cut those out, it would make that 200 look like it wasn't as extreme as it actually is, right? You can see 200's a pretty long way from the other scores, so that student could possibly be an outlier. but we'll see that in a future problem. Okay, so there we are. There's our stem plot. Remember, we do need a key, right? Otherwise, I don't know if this represents 101, 103, 109. It might represent 10.1, 10.3, or 10.9, or many other choices, right? So I want it to represent 101, so that means I need to make a key. So I'm going to show my key that I'll say 9/7 equals 97. Okay. I don't like using 10 whatever as my key because then my vertical line can get kind of confusing, right? So if you used your first entry and you did 10/1 for your key, it'd be easy to misread that. So that's why I kind of went back and made up a number that's not even in the data set, but that's okay. It tells the reader how to read the plot. All right. Now, please read these things thoroughly because sometimes not only do they have questions that you need to answer, but sometimes they actually give you some useful info. So you'll see the overall shape of the distribution is indistinct. This often happens when only a few observations are available, right? So we only have 18 observations. So when you kind of look at that plot, nothing really stands out at you other than maybe this score of 200 is a bit extreme compared to the other scores. Okay, question 2. Let's find the 5-number summary. All right, so jumping down here, question 2, 5-number summary. First number is the minimum, which is 101. Okay, last number max, 200. Okay, now if I wanted to do this by hand, there's 18 values, so I could go 9 in from each direction and then take the average of those 2 middle numbers. Or, again, feel free to use technology. Our calculator is really handy. It can find this very quickly for us. So a couple ways to do it. One way is, again, go to Stat, and now we can choose Calculate. And if I do one variable statistics on list 1 and hit Calculate, it's going to give me a lot of cool stuff. It gives me the mean, it gives me the sum of all the data, the sum of the data squared, various standard deviations, how many pieces of data are in the list. There's my min, and hey, look, there's my quartiles. So those are the numbers I wanted. I'm going to just go ahead and copy them from the calculator. Makes my life a little easier. So quartile 1 is 126. Quartile 2, also known as the median, 138.5. And quartile 3 is 154. Okay. That's one way to do it. Later on when we make a graph, I'll show you another way you could get those numbers. Okay, question 3. Determine if there are any outliers. Don't just say yes or no, right? So show your calculation, show your work as to why you have outliers or not. Okay, so finding outliers. Step 1, you have to calculate your interquartile range. Remember, that's Q3 minus Q1. So in this case, that would be 154 minus 126, right? There's my interquartile range, which is 28. Okay, now on the lower end, I'm going to take quartile 1 and I'm going to subtract 1.5 of these interquartile ranges. So it's going to be 126 minus 1.5 times 28. And that's my lower bound or my lower cutoff. Okay, so my lower bound will be 126 minus 1.5 times 28. And that's going to equal 84. Okay, so any score below 84 in this data set would be an outlier. But we don't have anything that low, right? 101 is our minimum. And we didn't really suspect a low outlier looking at our data set. It's the 200 that really has a possibility to be an outlier. So let's do the upper bound for our outliers. So our upper bound, okay, now we're going to take our third quartile, which was 154. And we're going to add, again, 1.5 or 1.5 interquartile ranges. And that will be the cutoff on the upper end. Sorry. So when we calculate that, we get 196. Okay, so any piece of data in this list above 196 is an outlier. And sure enough, that means that 200 qualifies as an outlier. Okay, so I'm going to say yes. Oh, extra S on yes. Very emphatic. Yes! So yes, 200 is an outlier as it is more than 1.5 interquartile ranges above third quartile. And there you go. So we found we did have one outlier for that data set. All right, question 4. Make a back-to-back stem plot with the men's data added to your original data set of the women's. Okay, so that's kind of why I was covering this up earlier. I had this set up. It's always a good idea to read ahead. I already had this set up and I left some space so I could go ahead and just add on to. So this is question 1 and question 4. That pen doesn't work. And question 4. Okay, so I have stem plot there on the right for the women. I'm going to do one for the men. And it's the same procedure. I entered the data, this time into list 2. Right, you can see that's the data that was given. So now again, I'm going to sort that data. So I go to list, operations, I'm going to sort ascending, and this time I'm going to do it, on list 2. Messed up there, try that again. Operations, sort ascending, and list 2. Okay, so that's right above the number 2. I hit second and number 2. Hit enter, it's executed it, and now the men's data is sorted least to greatest. So I can see my lowest score there is 70. That's why I have a stem of 7 in my stem and leaf plot, because I don't want to make a whole new stem and leaf plot. Why not just do it once? So here we go. 70, 75, 88, 91, 92, 104, 108, 109, 113, 14, 15, another 15, 26, 132, 140, 146, 151, 169, 180, 187. Oh, and by the way, it's always a good thing to check. Notice, I love this about the calculator. It says list 2, entry number 20. And so that's a nice thing to check. It said we had 20 pieces of data. So again, that means I didn't leave anything out. So anytime I use my calculator, when I'm done, I always like to double check that the sample size matches how many numbers I got into my calculator. Might have pressed the wrong button in there somewhere, but I at least have 20 pieces of data in my calculator as I should. Okay, so we now have our back-to-back stem plot. So we can see the men on the left and the women on the right. Now, a lot of students move on, but please, again, remember, finish reading. We made the back-to-back stem plot, but there's a follow-up question. What is the most noticeable contrast between the two distributions? Okay, so in other words, read it. Compare. That's the whole point of the graph. What do we notice? Okay, I'm noticing the men's data is centered in a lower region than the women's data, right? So the women seem to have, on average, higher scores. And that's the thing. It's on average, right? Some of the men scored well and some of the women scored lower than that. But the average of the men is certainly lower than the average score for the women. So that's my most noticeable contrast between their distributions. So it appears women score higher on average, right? Key to say on average because not every woman scored higher, right? The average of the group scored higher. Okay, and that's one of the things about statistics. A lot of people will read a statistic or they'll hear something and they'll go, well, that's not true. I know one person that bucks that trend. Well, that's not what statistics is about, right? There's women that have scored lower than some of the men, but that's not what we're saying. We're saying that on average, typically, okay? Not always, it's not universal, it's just typical. Okay, moving on. Number 5, do a 5-number summary for the men's data. Okay, again, it's real easy. I can already see the min and max from my stem plot. Min is 70, max is 187. And there's 20 pieces of data, so I could count 10 in from either side and find the average of those two values. But why not use our calculator? That's why we have it. It can be very tedious, especially with longer sets of data. So that's why we're going to use our calculator in class and on the AP exam. Okay, so again, we go stat, go to calculate. This time when we do our one variable stats, we're interested in list 2. And scrolling down, we can see quartile 1 is 98. Quartile 2, also known as the median, 114.5. And quartile 3, 143. So there we go. There's our 5-number summary. Okay, question 6, just like we did earlier for the women's data, do we have any outliers in this data set? So again, you need to show your work. Okay, so step 1 for calculating outliers is always, what's the interquartile range? So that's going to be 143 minus 98. So that's going to give me 45. Okay, so the men's data set has an interquartile range of 45. Okay, now to get my lower bound, okay, I'm going to take quartile 1 and I'm going to subtract 1.5 interquartile ranges. And that's the lowest value that's allowed in the data set to not be an outlier. Okay, so that's going to give me 30.5. And again, my minimum was 70, so no outliers on the lower end, which looking at the stem plot, it doesn't appear there were any outliers there. Probably no outliers on the upper end either. 187 has a chance, but it's not that extreme compared to the other values of 180, 169, etc. But we do need to, again, show our work to validate the answer. So let's do the upper bound. Okay, we're going to take quartile 3, 143, and this time we add 1.5 interquartile ranges. And we're going to calculate that, and we get 210.5. So sure enough, 187 is not an outlier. It does not exceed the upper bound of 210.5. So for this distribution, we can say there are no outliers in the men's data set. Okay, hopefully that's pretty simple. Now, when I do question 7, I'm actually going to see the answers that I already did in questions 2, 3, 5, and 6. The graph is very telling. So here we are, question 7. Make side-by-side box plots that plot outliers separately. Okay, so what I'm going to do, I have the data in here. In order to make box plots, I'm going to go up here to stat plot. In other words, statistical plots. So I hit second, I go up there. Okay. Now I can have multiple plots turned on. I could have one plot turned on. Heck, I could have them all turned off if I want. You'll notice I already have 2 of them on, but I'll go over how to do that. So I would just choose a plot, hit enter. Here's where I could toggle. Now it's off. Go to the left, hit enter. Now it's back on. And here's the different types of plots I can make. Notice there are 2 box plot choices. The first one has a little dot out there telling me, hey, this one does show outliers, plots them separately as they asked me to do. The second does not look for outliers. So that one's a modified box plot. The second is a non-modified. So I want to do a modified box plot, list 1. Okay, that's the women's data. Now I can go back up top, hit enter, and this time I can hit enter on plot 2. I can turn it on, and I can do the same setup, modified box plot, but now I'm telling the calculator, use the data that's in list 2, okay, for the men. Okay, now it's all ready to roll, but if I just hit graph, I may or may not have a nice viewing window. So the best way to ensure that you have at least a good starting window to look at your graphs, we use the zoom key. So I press zoom right there. There's a lot of choices, but there's one set up specifically programmed for statistical plots. So I'm going to choose zoom 9. And now when I hit enter, it will graph it, and the calculator will choose what it believes to be a good viewing window for the plot we're making. And there we go. We now have both sets of data plotted along the same scale. So we can very quickly compare their minimums, their first quartiles, their medians, their third quartiles, their maximums, either including or excluding outliers. So pretty darn handy. Now this is called a side-by-side box plot, even though they are kind of on top of each other. If you really, really want it to be side-by-side, well, here you go. Now it's a side-by-side box plot. And by the way, it's perfectly acceptable to graph it this way or the way your calculator did. I kind of like it this way. But the key thing I really have to stress, the plots need to be on one scale. They need to share that x-axis scale so that you can quickly see which graph is outperforming the other. Okay, every year I see students make their plots and they put them on 2 separate scales, and now you have to bounce back and forth, and it's really difficult to compare. Okay, when you put them on the same scale, it's very easy to compare. So there's the answer for question 7. Okay, guess I'll go ahead and do it by hand. So, and I'll just basically copy what's on my calculator. Now, here's how I can copy it. I already have the 5-number summary. I could just refer to that. But let's say I hadn't done the 5-number summary. I just wanted to do the plot. If I press this trace button, I get a cursor that pops up. And the cursor, it's currently on the median of the women's data, but by using the arrow keys, I can scroll through and I can see the 5-number summary. And I can also get one bit more information. I can see the largest value that's not an outlier. So I can just copy these values onto my graph very quickly and easily. So that's what I was saying earlier. For question 2, if I wanted to get the 5-number summary, I could have graphed it and scrolled through here rather than saying calculate one variable stats. And on the outlier question, I could have also very quickly seen, yes, 200 is an outlier. However, I would not have had the work to back that up. So you do need to know how to do that work. All right, so I'm going to go ahead and put these on my paper. So let's see, 70 for the men. And then we have 98. Median 114.5. third quartile of 143, max of 187. Okay, and again, if you're being really precise, go ahead and use a ruler for this, but you get the gist of it. Okay, do the same thing for the women's data. Minimum is 101. First quartile is 126. Median 138.5. Third quartile 154. Largest non-outlier 178. And then outlier of 200. And there you go. Our side-by-side box plots that are modified. Now there's one thing missing. Whenever you do a side-by-side box plot, you do need to label which data set is which. So here we go. This is the women, and this is the men. Okay, hopefully that's a piece of cake. Now we've actually made two of the best graphs for comparing when you have two sets of data. Okay? Earlier we did the back-to-back stem plot, and now we've done the side-by-side box plots modified. Okay. Looking at both of those plots, you should come to the same general conclusion, right? It looks like the women have higher scores on average. Okay. Which kind of leads us right into the final question. Write a summary paragraph that describes what you've learned. Okay. I'm not actually going to write it. I don't want you to copy my paragraph. You may have learned something that other people didn't learn. I'll just talk about some of the things that you may have noticed. Okay. So first you could talk about the actual data. What did you learn about this particular set of data? Well, I learned that on average it appears that the freshman women at this selective private college are scoring higher on average on the survey of study habits and attitudes. Now, here's some things I see students write that are incorrect. Some students overgeneralize these results. So they write things like, it appears women are smarter than men. They might throw on average in there or not, who knows? But please understand, this data came from a single private college, and it only came from a single class. So we can't even generalize this to all colleges. We can't generalize it to all classes at this college. We can only talk about freshman women versus the freshman men at this particular college for this particular freshman class. Okay. That's crucial. That's a very big concept in our class. It's a very commonly misunderstood thing in statistics. Statistics are often misused, and that's one of the ways that they're misused. People tend to overgeneralize the results they get from a data set. Okay, so again, only, and this isn't just for this problem, this is for the entire class, only apply your conclusions to the population that the data came from. Okay, do not overgeneralize your conclusions. Okay, other things you could talk about, aside from the data set, you could talk about the different graphs. Okay, hopefully you've learned that the two best graphs for comparing two sets of data would be a back-to-back stem plot and a side-by-side box plot. Excellent graphs for that purpose. However, notice if we had three sets of data, the back-to-back stem plot would be out of luck, unless you somehow made like a three-dimensional one. However, the box plots, you could stack as many as you wished. So that would be an excellent graph if you have three or even more sets of data that you want to compare. Okay. Other things you may have learned, about the 5-number summary. You may have learned about calculating interquartile ranges and the formal way to calculate for outliers. Okay, so again, feel free, write about whatever it is that you learned, whether it be specific to the data set or whether it be more general to statistics. Hopefully you learned something that you can apply in the class throughout the year. And please understand one other thing I want to point out. It says the word paragraph. If you're unsure what the definition of a paragraph is, I suggest ask your English teacher. Or I suppose you could look that word up in a dictionary if you're unsure what paragraph means. Because there's always a student or two that says, this is a math class. I'm going to write 3 or 4 sentences. Realize 3 or 4 sentences does not constitute a paragraph. Okay. All right, I hope this was helpful. So please correct any mistakes that you made on your special problem before you submit it, and hopefully that way we'll all get good grades. And of course, please study this, not just for chapter 1 before our test would be a great idea, but also for the AP exam, because again, this is helping to prepare you for an FRQ on the AP exam. Thanks for watching.